All right, this is going to have a couple new features. We're going back to polynomials. So our f of x is 2x squared minus 5, and we're going to the x-axis over the interval 0 to 2, so this is a and b. We're using 4 rectangles. So here's my end, and then we'll need to use this at the end when we choose our sample points. So let's start by computing delta x as always. So our widths will be given by delta x, and the formula is always b minus a over n. B is 2, a is 0, and then n is 4. So this is 2 over 4, or 1/2. So this is the first time we've had, oh, I guess we had pi over 4 as a width, but this is the first time we've had non-trig example with smaller than, or not whole number widths. But we'll see how that goes. And then, so what's going to happen with the heights? Something that hasn't happened in any of our examples yet. So let's go over here and sort of think about what these look like. So we're starting at 0. So here's what the function looks like. It's a sort of a steeper parabola scooted down 5. So that's why we're down here. And then the width of each of our intervals should be 1/2. So starting at 0, which is a, I'm going to go over 1/2. And then if I go half again, I'm at 1. So here's the next interval. And then the next one, half away from 1 is 3/2. And then I'm at 2, and then that's it. So these are my 4 bases of my rectangles. 0 to 1/2, 1/2 to 1, 1 to 3/2, 3/2 to 2. And so since I'm using right endpoints, I'm using the right ends of each of these subintervals. So my first one is 1/2. My next one's 1. My third one is 3/2. And my last one is 2. Okay, so how does this affect what's going on? So one thing to notice over here is that our function actually goes under the x-axis, and that hasn't happened yet. And that's why I keep saying between and not under as we get these examples, because actually the area that goes under the x-axis we're going to measure as negative area, and we're going to see this happen here right now. So when what happens when I plug 1/2 into our function is we're going to get a negative number. All right, so let's do that. So it's going to be 2 times 1/2 squared minus 5. 1/2 squared is 1/4, right? So we're going to get 2 times 1/4 minus 5, which is 2 times 1/4 is 1/2. So 1/2 minus 5. 5 is 10/2, and we're subtracting 1, so this is 9/2. So this is negative 9/2, which is the same as negative 4.5. Right? All right, and then 1 squared, 2 times 1 squared minus 5. So square 1 is just 1. So it's 2 minus 5. So here's negative 3. So we're coming up. So this should be not to scale again, obviously. Sorry about that. And then if we plug 3/2 in, we're getting closer to 0, but not quite. This is 9/4 times 2. So this is 9/2 minus 5, which is 10/2. So this is negative 1/2. And then the last one, if I plug in 2, I actually get above 0 finally, because 2 squared is 4 times 2 is 8, so this is positive 3. So what does that mean? So ignore my scale on my y-axis. So let's draw these. So the first one goes up to here, so I'm using right endpoints. And this rectangle is going to have negative area because the height we're using is going to be negative 9/5, and the width will always be positive, in this case 1/2. And then the next one should stop at 3, but I didn't draw the picture very well, so it didn't. And the next one goes to here. Then finally, so this should be 1/2, and the next one is 3. I guess we could make this one look correct. And that's the last one. So these three rectangles are going to give us negative areas, and this will be a positive one. So let's see what the area looks like when we try to compute it. Oh, sorry, this should be 9/2. Okay, so the area is approximately, let's not factor it out first, so it's going to be negative 9/2 times 1/2 plus, maybe we'll do this, negative 3 times 1/2 plus negative 1/2 times 1/2 plus 3 times 1/2. Oops. Yep, that's right. Here, let me make this look the same. Plus 3 times 1/2. Right. These 1/2s are all the same 1/2. They're the width of the rectangle. I'm going to factor that 1/2 out and just add the heights together first, and then multiply it at the end times the width, delta x 1/2. Okay. And the reason is because we're going to get some nice cancellation, right? These threes are the same, so and one's positive, one's negative, so that's 0, and then negative 9 minus 1, that's negative 10/2. Negative 10/2 is the same as negative 5, and so we end up with negative 5/2 is the answer. So just a note here, we can have negative areas. And we'll see why we'd want that when we start sort of doing applications. But any area that's underneath x, the x-axis will be counted as negative.